This video teaches how to convert units from one type of measurement into another. Before we get started, let's cover some basic math that we need to use to be able to convert units. First of all, what's the only number that we can multiply anything by and still get that original anything? That would be the number 1. Whatever it is, x, could be 27, 98, whatever. X times 1 is always equal to x. 5 times 1 equals 5. Negative 32 times 1 is negative 32. 1/8 times 1 is 1/8. 2 people times 1 is 2 people. And 3 penguins times 1 is 3 penguins. We also need to know what the magic number is that can divide any number and not change its value. X divided by what would still be x? Again, it's the number 1. Anything, x divided by 1, is still that original anything, that x. 5 divided by 1 is 5. Negative 32 divided by 1 is negative 32. 1/8 divided by 1 is 1/8. 2 people in one group would be 2 people per group. And 3 penguins distributed between one pile would still have 3 penguins in each pile. What can we divide a number by if we want to end up with an answer of 1? We divide it by itself. X divided by x equals 1. 5 things split into 5 piles equals 1 thing per pile. 2.7 divided by 2.7 equals 1. 1/8 divided by 1/8 equals 1. The only exception to this rule is 0, because 0 divided by 0 is considered undefined. But that's not going to affect us. All we need to know is that something divided by itself will equal 1. Converting units uses a lot of division and fractions. Division symbols include the traditional symbol, a fraction with a horizontal line, a fraction with a diagonal line, and the long division. Keywords, besides divided or over for fractions like 1/4, include how many per group, or being split into groups, or shared between groups, or how many does each get. There are a few important rules for fractions. First of all, when you're multiplying fractions, you can create a new fraction in which the top, that's the numerator, is created by multiplying the tops of the individual fractions, and the bottom, the denominator, is created by multiplying the bottoms of the individual fractions. So if you have a over b times c over d, you can create a new fraction, which is a times c over b times d. Canceling can also occur when multiplying fractions. If something in the top is identical to something in the bottom, they can cancel out, and then you only need to deal with what's left. Finally, if terms are being multiplied within fractions, just like multiplication can be reversed because the order doesn't matter, that's true within the multiplied parts of the fraction as well. So instead of a times b times c on top, you could have c times b times a. Or instead of d times e times f on bottom, you could have f times e times d. Also, if you're dealing with variables, you can eliminate the multiplication sign. And instead of b times a times c, you can just write bac. Or instead of f times d times e, you can write fde. So to summarize, any number times 1 is that original number. Any number divided by 1 is also that original number. And then any number divided by itself, except for 0, is equal to 1. Why are we making such a big deal about units anyway? Isn't it the numbers that matter? Suppose I answer the phone one day, and it's you. Miss Amy, please help us. The floor is lava, and it's rising. We can't get out of our house. Please bring the special lava-resistant boots you have and rescue us. Of course, I say. How many? And you say, 4. Okay, I'm on my way. Here I come. Only to discover, when I come to you, that when I asked how many, I meant how many boots. And when you answered how many with 4, you meant 4 people. So now, as you're trying to hop your way across the lava with one boot each, you're thinking, I really wish we'd paid more attention to what units we were talking about. Okay, I know what you're thinking. You're thinking, Miss Amy, this is completely unrealistic. It could never happen. And I admit it's a stretch, but I did some research. And last month, I actually answered my phone 8 times. So I figure if you can get me an answer to the phone, the floor is lava and the magic boots, that's a piece of cake. But seriously, if you are in trouble, just text my teens and have them get me. Don't try to call me. Hopefully by now I've convinced you that units matter. But why would we want to change units? This is Tommy. He just fell down and got a boo-boo. He wants his mom. If Tommy goes to get her, he'll call her Mom. If his friends go to get her, they'll call her Mrs. Chin. If another parent goes to get her, they'll call her May. It's the same person, but different names for different situations. Suppose you're baking a cake. Would you rather know that you need 2 eggs or 1/6 of a carton? Probably just the 2 eggs. You could figure it out either way, but one's just quicker and easier. But if you ran a bakery and you needed lots of eggs, would you rather know that you needed 96 eggs or 8 cartons? In this case, you'd probably rather know how many cartons you needed. In each situation, there's 2 ways of telling a person the same amount. But depending on their situation, there's a different way they'd rather be told the information that's easier for them. So the key to changing units is to multiply the original quantity you have by something special that will let the amount remain the same, but will change the name. How do we do that? We multiply by a very carefully chosen fraction. That fraction will not change the overall value, but it will change the type of units. How do we find the special fraction that does not change our value, but does change the units? First of all, how do you multiply by something without changing the value? That means you have to multiply it by 1. The second question is, how do you have a fraction that is equal to 1? The way to have a fraction that's equal to 1 is to have the top and the bottom be equal to each other, or equivalent to each other. They don't have to be the same number, but the same value. So 12 inches and 1 foot have the same value. They're equivalent to each other. And finally, how do we get the units to change? This is the tricky part, but we can break it into steps. First, in your special fraction, you're going to put the units you currently have in the bottom of the fraction. That way they'll cancel out with the current units. Next, you're going to put the units you want to end up with in the top of the fraction. And finally, you can't just put words wherever you want. You have to make sure that fraction is equal to 1. So you're going to put numbers in front of each of your units so that the top and the bottom of your fraction are equivalent. Let's do some examples. How do we convert 15 inches into the equivalent number of feet? Well, we're starting with 15 inches, so we write that down. And then we know we're going to multiply by a fraction. So go ahead and set up the fraction. And we know that we need that fraction not to change the overall value, but we do need to change the units. So first thing we do is we set up the units. In the bottom of the fraction, we write the units we already have, which is inches, 15 inches. In the top of the fraction, we write the units we want to have, which is feet. We want our answer in feet. Now, what can we do to make the top in feet equal to the bottom in inches? What facts do you know? You know that 12 inches equals 1 foot. So make yourself a little number sentence where you say that something about the top of the fraction equals some amount in the bottom of the fraction. So how many feet equals how many inches? That would be 1 foot equals 12 inches. So fill that in. So now we still have our 15 inches, that's our value, and we're going to multiply it by 1 foot over 12 inches. And since 1 foot over 12 inches, 1 foot is 12 inches. So dividing it by itself is just 1. And multiplying by 1 doesn't change the value. So we're good. We haven't changed the value of our 15 inches. What's next is we need to multiply. But if you're not comfortable with fractions, this might make you uncomfortable having a non-fraction times a fraction. And remember, you can always divide a number by 1 and you're not changing that number. So if it helps, go ahead and set, instead of 15 inches, set it up as 15 inches over 1. Now we're still multiplying by our special fraction that's equivalent to 1, but lets us change our units. So that's 1 foot over 12 inches. Now we can cancel. When we're multiplying fractions and there's something in the top that matches something in the bottom, you can cancel. So those inches cancel, and what we're left with, we can multiply. When you're multiplying fractions, you can multiply everything on the top, put it in the top of your new fraction, multiply everything on the bottom, put it in the bottom of your new fraction. So at the top, we have 15 times 1 foot, and at the bottom, we have 1 times 12. Notice there's no units left in the bottom. Now we can simplify. We have 15 times 1 is 15. 1 times 12 is 12, and I'm going to pull the feet outside and say I have 15 twelfths feet. We can do the math to reduce that. You can either take it down to a improper fraction or a mixed number or a decimal, depending on what your book wants you to do, what your teacher wants you to do. I'm just going to write it as a decimal, so 1.25 feet. So 15 inches is equivalent to 1 1/4 feet. We haven't changed the value. That is the same length. It's just a new name, a new way of expressing it. Let's keep practicing. How can we convert 6 centimeters to inches? First of all, I'm going to go ahead and write down what I know to help me convert later, and that's 1 inch is approximately equal to 2.54 centimeters. So I'm going to put that up at the top as one of the things I just know. I'm starting with 6 centimeters, and now I'm just going to make a habit of going ahead and making that over 1, so I already have it as a fraction. So I have 6 centimeters times our special fraction. Our special fraction has to have the units in the right places, and that's going to be centimeters in the bottom, so it cancels out with what we already have, and inches in the top, so that's going to carry through to our answer. Now, what's the word sentence that will let us make that fraction equal to 1? The top and the bottom have to be equal, and that's 1 inch equals 2.54 centimeters. So that's how I fill that in. All right, now we're ready to cancel. We can cancel our units, our centimeters cancel out, and we can combine all this multiplication into one fraction, 6 times 1 inch over 1 times 2.54. We do the math. We get 6 over 2.54 inches, and now we can simplify to get our final answer, and we get 2.36 inches. Let's convert 8 yards into feet. We know that 1 yard is equal to 3 feet. So again, we're starting with 8 yards, and you're welcome to put it over 1 if that helps you keep track of your fractions better. We're going to set up our fraction so that the yards are canceled, so we put yards in the bottom. The feet flow through to the answer, so we put feet in the top. And what can we make that fraction so it's equal to 1? Well, 3 feet equals 1 yard, so we're going to fill in the 3 on the top, the 1 on the bottom. Ready to cancel, the yards cancel out. That leaves us with 8 times 3 feet in the top, 1 times 1 in the bottom. That's 24 over 1 feet, which is 24 feet. All right, convert 2/3 cup of butter to tablespoons. And I went ahead and threw butter in here just for fun. We've been doing things without saying what we were converting much of, but let's just say it's butter we're measuring. So we have 2/3 of a cup, but you know how those sticks of butter have tablespoons marked on them. How do we figure that out? All right, so I have 2/3 of a cup over 1 is what we've been doing, and I'm going to multiply it by our special fraction. But you notice 2/3 already is a fraction. So if you wanted, you could actually set it up as a fraction to start with. Just make sure when it's 2/3 of a cup, that cup goes on top. It doesn't go on bottom. That's 2/3 times a cup is basically what you're doing. So it's 2 cups divided into 3 parts. So make sure that C is in your numerator on the top. So I've got 2 cups over 3, and I want to convert that. So I'm going to put my units for cups in the bottom of the fraction and my tablespoons that I want to end up with in the top of the fraction. So now I've got 2/3 of a cup times 16 tablespoons over 1 cup, because 16 tablespoons is equal to 1 cup. I'm going to cancel out my cups. I'm going to multiply everything so it's in one fraction now. Simplify the top and simplify the bottom. And then pull out my calculator or do some mental math to figure out that 10 2/3 tablespoons is equal to 2/3 of a cup. Let's convert a quarter mile into feet. In other words, let's find out how many feet are in a quarter mile. So 1 mile is equal to 5,280 feet. That's the fact we're going to need to know. We're going to take that quarter mile and we're going to set up the fraction we need. That lets us keep the value but change the units. We're also going to take that quarter and move it down to the denominator. So it's going to be 1 mile over 4. Our special fraction will have miles in the bottom, so it cancels those out. It'll have feet at the top, so the feet flow through to the answer we're looking, which is how many feet are in a quarter mile. Since there's 5,280 feet equal to 1 mile, we're going to fill in the numbers with 5,280 on top, 1 on the bottom, because now that fraction's equal to 1 because the top and the bottom are equal. Cancel out miles, let the math happen, and you're going to get your answer of 1,320 feet. Now, if you're comfortable with fractions, you may have noticed you could have done a little more canceling up here. And if you saw that, that's great. It would just save you a little bit of math as you walked your way down. But if you missed it, it's okay. Canceling just lets us take a little shortcut, do some work ahead of time. If you follow the procedures, you're still going to get the right answer. So if you missed that opportunity, no big deal. What if instead of a quarter mile, they'd phrased it as a decimal? What if they'd said 0.25 miles? Same thing, different name. You can put a decimal in a fraction if you want to. You don't see it very often, but you're just doing your own work, right? So you could have put your decimal right here, and as you worked through it the exact same way, you would have ended up coming to this point. And when you plugged 0.25 times 5,280 all over 1 into your calculator, you would have gotten the exact same answer. All right, how many pounds is equivalent to 60 kilograms? What you need to know is there's approximately 2.2 pounds per kilogram. So we're going to start with our 60 kilograms and set up our equation. We want to cancel kilograms, so we put that on the bottom. We want pounds to be in our answer, so we're putting that in the top. Remember, LB is the abbreviation for pound. So that sentence we want to say starts with the top, and that's pounds. So that's 2.2 pounds is equal to 1 kilogram. So we fill that in to make our fraction equal to 1. We cancel. We do some math, and we end up with 132 pounds. Convert 1 1/4 gallons to ounces, or like it might be phrased, how many ounces are in 1 1/4 gallons? What we know is 1 gallon has 128 ounces. So the important thing to know here is when you have a mixed number, if you want to use that number in all your fractional stuff, you really need to go ahead and put it as an improper number. Technically, it's possible to work with it as a mixed number, but you got to be super careful. So let's go ahead and go with an improper number. So instead of 1 1/4, let's do 5 quarters, because 1 would be equivalent to 4 quarters by itself, plus the extra quarter makes it 5 quarters. And once you know this, everything's just like we've been doing before. So we're going to set up our fraction. We're going to move that 4 down to the bottom, so it's 5 gallons over 4 is equal to how many ounces over how many gallons? That'd be 128 ounces over 1 gallon. Our gallons will cancel. We're going to do the math, and we're going to find out that's 160 ounces. All right, these last two examples are more advanced examples, so you might not need to do these right now, but I did want to show you that you can keep working with this even when it's not quite as straightforward. So first of all, how would you convert 2.5 feet to centimeters? Now, off the top of my head, I do not have anything memorized that lets me convert feet to centimeters. I mean, I could ask Google. Google would definitely know, but I'm going to go with what I know. And what I know off the top of my head is there's 12 inches in every foot, and an inch is approximately 2.54 centimeters. So if I can go from feet to inches, and then I can go from inches to centimeters, I'm good. So let's start there. 2.5 feet, we want to take that to inches. I'm going to simplify a few of the steps now. We're going to set up our fraction. 12 inches equals 1 foot. We do the math after we cancel, and we get 30 inches. So 2.5 feet is equal to 30 inches. Now let's take that 30 inches and convert it into centimeters. So I've got my 30 inches. I'm going to cancel my inches and bring in centimeters. So my fraction is 2.54 centimeters is equal to 1 inch. And I end up with 76.2 centimeters. So this just shows you where you can do it in steps, where you can convert from one unit to another unit, and then from that unit to yet another unit if that's what you need to do. Our second advanced example is a polar bear runs 220 feet in 0.1 minutes. What is its speed in miles per hour? Well, speed is distance over time, but if we plug in 220 feet in 0.1 minutes, we get speed in feet per minute, not miles per hour. So how do we handle this? I'll show you two options. Option one is probably the better option to start with if you're new to this. What you do for option one is you convert your feet to miles and you convert your minutes to hours before you solve the problem. So 220 feet, convert it like we've been practicing this whole video, it's 0.04167 miles. 0.1 minutes, convert it like we've been doing, and you get 0.00167 hours. Plug those two values into speed equals distance over time, and you get 24.95 miles per hour. The other option is you can solve with the quantities you were given in the problem and then figure out how to convert. So if you had 220 feet in 0.1 minutes, that would give you 2,200 feet per minute. You take that 2,200 feet per minute, and what you have to do is you have to do two different fractions that will let you convert. So each fraction, has the same rules. It can't change the value, but it has to change the units. So you have one fraction that changes feet to miles, and one fraction that changes minutes to hours. So we have 2,200 feet per minute as our speed, and we set up 1 mile over 5,280 feet to convert from feet to miles. Then we set up 60 minutes over 1 hour. That will cancel our minutes and convert from minutes to hours. And if you do all the math, you end up with 25 miles per hour. You'll notice there's a little bit of a difference due to rounding. In the first problem, I cut it off after a few decimal places, but it is essentially the same answer.